So this was the question which we were discussing in the last session. As you can see, look, for example, if I say I start taking the picture, so this is the first picture I took. I took the picture from this point. So we took this as a first picture. So it means this is the time started. So it means at this point time is equals to 0. Okay. And then at this picture we stop. So the time interval is 2.47 seconds. The question is how many pictures are taken in 1 second. So how to work out number of pictures taken in 1 second? So you will not include this one because this is already taken. This is when time is equals to 0. After that, this is the first picture, then second, third, fourth, fifth, sixth, seventh, and then this is the eighth picture taken till the time interval of 2.4 seconds. So if there are 8 pictures are taken with a time of 2.47 seconds, so in 1 second how many pictures are there? X cross multiply, so it will be 8 divided by 2.47, which is 3.2 pictures are taken per second. Is it clear? Because that's the first picture we took, so means the time started. Like if we say a timer is there or stopwatch, so this is the moment we start the timer. That's why we did not count 9 pictures, it is 8. Then the vertical height between the second and the 10th picture is 30 meter. Take measurement from the photograph, use them to show the horizontal distances between 12 and 15 meter. Record your measurement below. So basically actual size is 30 meter. For the vertical distance, the second picture to the 10th picture, this is actually 30 meter. But what we do, using a ruler, we'll measure. This is the actual size. We'll measure the figure size. So figure size, we'll use a ruler here, the scale. It can be any number. So example, if it is coming out 10 centimeter, example. So 30 meter equal to 10 centimeter. Then what we do, we need the horizontal distance between the second picture and the 10th picture. We need this horizontal distance. So we'll do a measurement, like we'll measure, again I'm using a screen. So example, if this is 4 centimeter, so using a ruler, if this is 4 centimeter, then what will be the actual size? It will be X, because the scale won't change. Then we cross multiply. So it will be 30 multiplied by 4, which is equals to 120, and divided by 10. So 120 divided by 10, what we get? We get that as 12 meters. So this X will be equal to 12 meter in actual. Is it clear? So using a figure, we work out, as we know that the vertical distance is 30 meter. According to figure size, they mention already in the question that you have to use a figure to measure the distance. So that is coming out as example 10 centimeter. So the horizontal distance between the second and the 10th picture, if it is 4 centimeter, then in figure size it will be equal to 12 meters. Is it clear, this part? Calculate the horizontal velocity and vertical velocity of man for the 10th picture. So we need horizontal and vertical velocity of the man for the 10th picture. So already we have, we know this vertical distance is 30 meter. and horizontal distance we calculated, that's 12 meter. And the time it took to fall from the second to the 10th picture, that is 2.47 seconds. At the maximum height, the vertical velocity is horizontal will be there, but the vertical will be 0. So there is no vertical, there will be horizontal, but the vertical will be 0. The starting vertical 0. We need the final vertical, so we need V here. So what we can use equation of motion V is equals to U plus AT. So V is the final vertical, initial vertical is 0, gravity is 9.8 multiplied by 2.47. So this 2.47 multiplied by 9.8, so we will get 24.5 meter per second. That's a vertical velocity. So we got the vertical velocity, which is 24.5. What about the horizontal? Because the horizontal does not change throughout the motion, we have the range and we have the time, so we can use range or distance multiplied by time, or not multiplied, because we need speed. So speed or horizontal component is equals to distance or range divided by time. The horizontal component, the distance it's 12 and the time is 2.47. So that will approximately be 4 uh, 5.12 divided by 2.47. That's the answer. 5.2 meter per second. That is equals to 5.2 meter per second. Is it clear how we work out the vertical component of the 10th picture and the horizontal component? And that horizontal will be same throughout, because the initial horizontal will be 5.2 and the final, because we assume there is no air resistance. In practical, there will be air resistance, but we assume there is no air resistance. And acceleration is due to gravity, which is constant. An object is thrown horizontally. Which pair of displacement time graph correctly shows, this is a displacement time graph, and displacement for the object until it lands, assume that there is no air resistance. So which pair of displacement time graph correctly shows the vertical and horizontal? The horizontal component, there is no acceleration. So if there is no acceleration horizontally, there should be a constant speed. So if there is a constant speed, speed should not change. So the slope of a displacement time graph should be constant. And for vertical component, it is accelerating due to gravity. So what happened? It should accelerate. So which displacement time graph? This graph shows it is accelerating vertically, and this shows it is moving at a constant speed because the slope is constant. Here slope is increasing, so speed is increasing. It means it is accelerating. That's why C is the right answer for this. Is it clear? Question 5. A ball launcher fires a ball horizontally from the edge of a lab. The path of the ball after two launches are shown. Which of the following quantity is different? They have different range. So gravitational acceleration will be same. Time of the flight, because we know that even if I drop an object vertically down, this was object A, object B, and object C, they all will take the same time because they're vertically, they all have the same acceleration. So time of the flight, launching angle is already same, as you can see both are launched horizontally. Because they have different range, B travel more than A, so it means they have different initial velocity. Initial velocity of B is higher, that's why it will have a greater range as compared to that of A. So D will be the right answer for this question. An archer stands 15 meters from a target. So an archer is there, standing 15 meters from the target. An arrow is fired horizontally. So arrow is fired horizontally with a speed of 36 meter per second. Show that the time on the diagram path. So how to sketch a path? So it will be a which launch horizontally. So this will be the path. Maybe he's not able to hit the bullseye. So this will be the trajectory or the path taken by this projectile. Show that the time taken by the arrow to reach the target is about 0.4 seconds. So we have the range and we have the initial speed, and this is the horizontal speed because horizontal vertically it is 0. The initial vertical is 0, horizontal speed is 36. So we have the formula speed is equals to distance over time. So time is equals to distance divided by speed. Distance is 15 and the speed is 36. So what is the answer when 15 divided by 36? That's equal to 0.42 seconds. So that's about 0.4 seconds. So 0.416 seconds or 0.42 you can say. Then the archer fires an arrow horizontally from a height of 1.5 meter above the ground. Calculate the height above the ground at which the arrow strikes the target. So the archer is 1.5 meter, is firing the arrow with a speed, horizontal speed of 36 meter per second, and the horizontal distance this is 1.5 meter, not 15. That's 1.5, and the horizontal distance is 15 meter. Okay, and it was taking 0.42 seconds to reach the target. We want what is the height of arrow above the ground. So first we'll cover the distance traveled by the arrow, uh, the horizontal distance covered by the arrow. Sorry, vertical distance. So what we do, example, if the arrow strike this point, so we want to find this height first, the vertical distance fallen, and from vertical distance, total vertical distance minus 1.5, 1.5 minus the vertical distance fallen by this arrow, we will get this distance x. So how we can find the vertical distance? In we have the time Initial velocity is 0, so we have the formula S is equals to ut plus half at square. Initial vertical velocity is 0. So this whole factor will be 0, so it will be S is equals to 1 by 2 gt square, and time was 0.42. So this S is equals to 1 by 2 into 9.8 and 0.42 square. So the vertical distance, that is 0.87 meter, that is this distance which is fallen by this arrow. But we don't need this distance, we need the distance of arrow above the ground. So if it is launched from a height of 1.5 meter and it fall vertically 0.87 meters, so how much height is there above the ground? So that height above the ground will be equal to 1.5 minus 0.87, that's equal to 0.63 meters. So this height above the ground will be equal to 0.63 meters. Is it clear? Explain how your answer to B1 would affect if the archer stood closer to the target. So if archer is closer to the target and he is launching from the same height, so if he is launching from the same height, the vertical distance fallen will be smaller. So if this was 1.5, the vertical distance which it fall will be smaller. If the vertical distance which it fall will be smaller, the distance of the arrow above the ground will be higher. Is it clear? Because this value will decrease, so the value of x will increase, because 1.5 minus minus s is equals to x. So if the value of the s is decreasing, so value of x will increase. Is it clear, this part? That if the archer is standing closer, the vertical distance which the arrow will fall will decrease, so the height of the arrow above the ground will increase. The point where it hits the target, that will be higher as compared to the previous one. Then question 8, a plane is traveling horizontally at a constant speed. It releases the package. So what will happen when it releases? It cannot be A, because there is a horizontal component for plane, so there should be a horizontal component for package as well. So it will move horizontally for some, and then it will have horizontal and vertical component both. Why not D? Because D is for long period it is traveling, but there is air resistance, so it will not continue. There is also a vertical component, that's why it will not continue the horizontal component only for a longer period of a time. That's why C is the right answer for this. Another projectile question. A student is given the following information for a particular attempt at a goal. Initial velocity of the ball is 4.5 and the launching angle is 60. The horizontal distance from the center of the ball to the center of the ring So there's a ring through which he is passing. The horizontal distance is 1.5. Show that the time taken to travel the horizontal distance of 1.5 is about 0. So we have the velocity, but we don't have the horizontal component because speed is distance over time. We need the horizontal component of speed. So how to get the horizontal component of speed? Horizontal component of speed is written with cosine. So it will be 4.5 cos 60. The distance is 1.5 and the time is t. So t is equals to 1.5 divided by 4.5 cos 60. That will give us the time the ball will take to reach this ring. So it will be 0.67 seconds it will take to reach the ring. Then the next part, calculate the vertical displacement of a ball when it travels the horizontal distance of 1.5. Hence comment whether a goal will be scored. The vertical distance of a ring, the release point is zero point 0.7. So vertical distance of a ring from the point of release is 0.7 meter. So we have the horizontal distance, which is 1.5 meter, and the ring is there, which is, and normally this distance is given from center of the ring, that is 0.7 meter, and a ball is launched with an initial velocity of 4.5 meter per second, which was making angle 60. So we want to comment that whether it will pass through the ring. So how we can work out, basically we'll find that, and we already know when the time to reach this 1.5 meter horizontally, the time is 0.67 second. That's a time taken to cover. So first we'll find the height of the ball when it is at 0.67 second, and if the height of the ball is same level, then it will pass through. And to get the height, we need the vertical component. So this will be equal to 4.5 sine 60, the vertical component. So we use equation of motion, S is equals to ut plus half at square. Now the initial launching speed is 4.5 sine 60 because that's a vertical component, multiplied by time it took 0.67 plus 1 by 2, acceleration is due to gravity, minus 9.8, and 0.67 the time square. So this will give us the vertical distance, that is 0.41 meter. Or if we consider this as this distance was given, so the ball, when the time is equals to 0.67 second, the ball is only at a height of 0.67 0.41 meters. So if it is at a height of 0.41 meters, does this ball crosses the ring or it will miss the ring? The ring is 0.7 meter above the position where we kick the ball or hit the ball. So because the ball is at a lower height and the ring is at the above height, so it means this ball will miss the ring. Is it clear? Explain how air resistance would affect the calculation in B1. B1 is show that the time, so it was taking 0.6, so the ball will take, the horizontal component will decrease, so it will, the calculated value of the time will increase. Because in the B1 we calculated the time or showed the time, and speed is distance over time. If there is a air resistance, the speed will decrease. If distance is constant, so the time will increase. So it will take longer time to reach 1.5 meters. So these are some questions related to topic projectile. Any question related to the class today? Any question or a doubt? So I'll end the session and share this.